All right, so today we're going deep on something pretty wild in the philosophy of math.
Oh.
And it's this question of, could mathematical truths be false?
Oh, wow.
Like the stuff we think is like the bedrock of logic and science.
Right.
So this is a deep dive into mathematical fictionalism.
Right.
And it's kind of a mind-bending idea from the start.
Well, so what's fascinating here is that fictionalism is like a direct challenge to something that seems really intuitive, and that's mathematical Platonism.
Right.
So if you're a Platonist, when you think about what you're doing when you're doing mathematics, you're not just like moving symbols around on a page.
Yeah.
You're actually discovering truths about a real objective world out there.
Okay.
A world populated by abstract things like numbers and sets and functions and all the things mathematicians like to talk about.
Right, right.
So think about the number 3, for example. A Platonist would say that 3 exists in a very real sense. Even though it's not a physical thing like this table or a mental state in your head, it's out there outside of space and time.
Right.
And this is a view that's been held by some pretty big names in philosophy. Right, going all the way back to Plato himself, up through people like Frege Gödel, Russell Quine Putnam, just to name a few.
Yeah, so for a Platonist, when we say 3 is prime,
Yeah.
that statement is true because there really is this thing, this number 3 out there in this abstract
Right.
realm.
Right.
And it really does have the property of being prime.
Yeah.
It's true in the same way that we would say the sky is blue is true
Yeah.
because there's a sky and it has this property of blueness.
Yeah.
But here's where fictionalism comes in and throws a wrench in the gears.
Okay.
The fictionalist says, okay, we agree that our mathematical sentences, they look like they're about these abstract objects.
Right.
Like when we see 3 is prime, we kind of read that at face value as like a statement about the number 3.
Yeah.
But they say, no, those abstract objects don't actually exist.
Exactly.
Right.
And so if there are no mathematical objects, like the number 3, then sentences about them like 3 is prime can't be literally true.
Right.
So that's the core claim of fictionalism. And it's a little bit radical. It might sound crazy at first, but it's a serious philosophical position.
Yeah, so it's like if you were to say something like the tooth fairy leaves money under your pillow,
Right.
it sounds like you're making a statement about a thing.
Yeah.
But we all know the tooth fairy doesn't exist.
Right.
So the statement is false.
Exactly.
And the fictionalist is applying that same kind of logic to mathematical statements.
Right. So they're saying that the sentence 3 is prime is false, not because there's something wrong with 3 or with primeness,
Yeah.
but because the number 3 itself just doesn't exist.
Right. So to put it in philosophical terms, this is a type of mathematical nominalism.
That's right.
Right, which broadly speaking is just the view that mathematical objects don't exist.
Yeah.
And fictionalism adds this specific twist where mathematical statements, despite how they look, they're not literally true because
Okay.
they're referring to things that aren't there.
That's right. And it's important to clarify here that fictionalists aren't necessarily saying that doing mathematics is like writing a novel or reading a comic book or anything like that.
Right.
It's not about, it's about the truth, or in this case, the falsehood of mathematical sentences, if these things they're talking about don't exist.
Right. And the key figure that we should mention here is Hartree Field, who wrote this very influential book in 1980 that really set the stage for fictionalism as we know it today.
Exactly. And since Field's book, there have been other philosophers who've developed and kind of refined different versions of fictionalism.
Right.
People like Balaguer and Rosen and Yablo and Lang and Bueno and others. So there are some interesting nuances and differences in how they think about fictionalism.
Right. So at this point, you might be thinking, wait a minute, are you saying that like all those math facts I learned in school are actually false?
Right. It can sound a little bit wild at first. But the real philosophical interest in fictionalism comes from the issues it's trying to address with other views in the philosophy of math.
Right.
So the goal of this deep dive is to unpack the main arguments for fictionalism by looking at the philosophical landscape that it's reacting against.
Right. So the central argument for fictionalism, it often presented as an argument by elimination.
Exactly.
Right, where it's like if we can eliminate all the other alternatives, then fictionalism is what we're left with.
Right. So the argument goes like this, and it uses a series of premises, that if you accept them, it leads you to the conclusion that mathematical sentences aren't true.
Okay, so premise 1 is something that seems pretty straightforward, which is that mathematical sentences like 4 is even should be taken at face value.
Right. So when we say 4 is even, We really are talking about the number 4 and the property of evenness.
Right, so we're not like trying to reinterpret that in some other way.
Right.
We're just taking it as it is. And then premise 2 is that if we read these sentences at face value, and if they're true, then the objects that they're about must actually exist.
Right. So if 4 is a true statement about the number 4,
Mm.
then there really must be such a thing as the number 4.
Right, so that leads to the implication that if mathematical sentences are true, then mathematical objects exist.
Exactly.
And then premise 4 is that if mathematical objects exist, they're abstract,
Right.
meaning that they're not located in space or time.
Right. They're non-spatiotemporal.
Yeah.
Mm.
And so this brings us to premise 5, which is a really crucial point in the fictionalist argument. And this just says there are no such things as abstract objects.
Right.
And from there, using some basic logic, we can get to the conclusion that mathematical sentences aren't true.
Right. So let's break down how that logic works.
Okay.
So we have premise 4, which says if mathematical objects exist, they're abstract.
Right.
And premise 5, which says there are no abstract objects.
Right.
So from those two premises, we can conclude that mathematical objects don't exist using a rule of logic called modus tollens.
Right.
And then if we go back to the implication we got earlier, which was if mathematical sentences are true, then mathematical objects exist, and we combine that with our new conclusion that mathematical objects don't exist,
Right.
then we can use modus tollens again to get the final conclusion that mathematical sentences aren't true.
Right. And the fictionalist is saying each of these premises is meant to address a different alternative view in the philosophy of mathematics.
Exactly. So let's start looking at some of these alternatives and why the fictionalist rejects them.
Okay, so the first one we should talk about is paraphrase nominalism,
Okay?
which is going to challenge that first premise, the idea that we should take mathematical sentences at face value.
Right. So paraphrase nominalism is interesting because it's trying to avoid committing to the existence of mathematical objects by saying that when we make these mathematical statements, we're not really saying what it seems like we're saying. So instead, we have to paraphrase these statements or reinterpret them in a way that doesn't involve talking about numbers or other abstract entities.
Right, like what would be an example of that?
So one classic example is something called Fictionalism,
Yeah.
which is the view that a statement like 3 is prime isn't really a statement about the number 3.
Okay.
It's more like a conditional statement.
Like an if-then statement.
Exactly. If there were numbers, then 3 would be prime, or maybe something like necessarily if any system of objects satisfies the axioms of arithmetic, then in that system 3 would be prime.
Okay, so they're trying to like kind of sidestep the question of whether 3 exists by just saying, well, if it did, it would have this property.
Exactly.
But the fictionalist would say that just doesn't seem to match up with how we actually use mathematical language.
Right. It just doesn't seem very plausible, does it? Like when a mathematician is proving a theorem about prime numbers, they're not thinking, okay, well, if these abstract things exist, then...
Right. It seems like they're just talking about the numbers.
Right. And fictionalists often appeal to this idea of an interpretive principle, which says that we should interpret what people say literally, unless there's some really good reason to think they don't mean it literally.
Right. And with math, it seems pretty straightforward.
Exactly. It seems like we're talking about numbers as if they really exist.
And there's another interesting counter-argument that the fictionalist raises, which is that if the paraphrase nominalist doesn't actually believe their paraphrases capture the real meaning of what mathematicians are saying, then their view basically collapses back into fictionalism.
Right. So it's like they're saying, yeah, okay, mathematicians might be saying 3 is prime, but what they really mean is if numbers exist, then 3 would be prime. But if they don't really believe that that's what mathematicians mean, then they're basically admitting that mathematicians are saying false things.
Right.
And at that point, they're not really offering a genuine alternative to fictionalism. They're just a fictionalist who thinks that we should talk about math in a different way.
Right. Okay, so paraphrase nominalism is trying to say, we don't mean what we say. The next alternative, deflationary truth nominalism, tries to change what it means for mathematical statements to be true.
Okay.
And this is challenging premise 2, which is the idea that if a statement is true, the objects it's about must exist.
Right. So deflationary truth nominalism is a bit of a mouthful, but it's basically the view that you can have true mathematical statements even if the objects they're talking about don't exist.
Okay, how does that work?
Well, it relies on a deflationary theory of truth, which is basically the theory that says truth isn't this really deep thing. It's more like a linguistic device that we use to endorse or agree with statements.
Okay.
So a deflationary truth nonetheless might say something like 3 is prime as truths because we accept it, or it follows from our mathematical practices, or it plays a certain role in our reasoning, but it doesn't need a number 3 to exist to make it true.
But that seems to go against our basic intuitions about truth, right? Like if I said Mars is a planet, but it doesn't exist, that just seems like a contradiction.
Exactly. And that's one of the main objections that fictionalists raise against deflationary truth nominalism.
Okay.
They say it just doesn't fit with our basic understanding of what it means for something to be true.
And the other objection is that even if you accept this deflationary view of truth, it doesn't really help you avoid the problems that Platonism raises.
Right, because a Platonist could just say, okay, well, we're not interested in your deflationary truth. We're talking about truth in a stronger sense, like correspondence truth, where a statement is true if it corresponds to some fact about the world.
Okay.
And for a Platonist, that fact would be the existence of the mathematical object and its properties.
Right. So we're back to square one.
Exactly.
Okay,
Okay.
so paraphrase nominalism tries to change what we mean, deflationary truth. Nominalism tries to change what truth means.
Right.
The next set of alternatives is going to target premise 4, which is the idea that if mathematical objects exist, they're abstract.
Right.
And here we have physicalism and psychologism.
Okay.
So let's start with physicalism. What's the idea here?
So physicalism is the view that mathematical objects, if they exist, are actually physical things in the world.
Okay.
So a physicalist might say that 2 plus 3 equals 5 isn't about abstract numbers, but it's about like combining groups of physical objects.
Okay, so like if I have 2 apples and I add 3 apples, I get 5 apples.
Exactly. So math on this view becomes kind of like a branch of empirical science,
Yeah.
where we're just observing patterns in the physical world.
But how would that account for all the parts of math that seem to deal with things that aren't physical, like infinity?
That's the main problem that fictionalists have with physicalism.
Okay.
It just can't handle the idea of infinity because our physical universe, as far as we know, is finite.
Right. There's only a finite amount of stuff.
Exactly.
Okay, what about psychologism?
So psychologism is the view that mathematical objects are mental objects.
Okay, so like numbers are just ideas in our minds.
Exactly. So 3 is prime
Mm-hmm.
would be true because of something about our idea of the number 3,
But again, we run into that problem of infinity.
right? How could we possibly have infinitely many ideas in our minds when our minds are finite?
Right.
It just doesn't seem plausible.
And what if someone said, well, it's not about having infinitely many ideas, it's about having an idea of infinity?
Right, so that's an interesting response.
Mm-hmm.
But fictionalists would say it still doesn't really solve the problem because math is about the existence of infinitely many distinct mathematical objects,
Okay.
not just our ability to think about infinity.
Right, so it's not just that we can imagine it, it's that they're supposed to really be out there.
Exactly.
And if someone said, okay, well, it's about possible ideas,
Right.
then it seems like we're not really talking about psychologism anymore.
Exactly. Because now we're talking about possibilities which might themselves be abstract or at least not really mental in any straightforward way.
Right, so it seems like physicalism and psychologism both struggle to account for the full scope of mathematics, particularly when it comes to infinity.
Exactly.
So now we get to the final alternative, which is Platonism itself, which is rejecting that premise 5 that there are no abstract objects.
Right. And this is really the core disagreement between fictionalism and Platonism.
Okay, so what are some of the arguments that fictionalists use against Platonism?
So one of the most famous arguments is the epistemological argument, which basically says that if mathematical objects are abstract and outside of space and time, how could we possibly know anything about them?
Right, because we're physical beings stuck in space and time.
Exactly. So how could we ever interact with or come to know anything about these abstract objects?
But haven't Platonists come up with responses to that?
Oh, yeah, they've got a lot of responses.
Okay.
They might say, for example, that we can know about abstract objects through our reasoning or through the role that math plays in science,
Okay.
or maybe through some kind of special intuition that we have.
Okay, so it's not like a settled issue.
No, it's a very lively debate.
Okay, and another argument is the multiple reductions argument.
Right. So this argument points out that there are many different ways to define mathematical objects in terms of sets. And if these objects were really real and independent of us, then there should be one best way to define them.
Right, like there should be one true definition of what a number is.
Exactly. But it seems like there isn't.
And what do Platonists say to that?
Well, some Platonists say that there is one best definition, we just haven't found it yet.
Okay.
And others say that it's okay to have multiple definitions.
So again, it's still up for debate.
Yeah, it's a tough one.
Okay, and then there's the argument from Occam's razor.
Right. So Occam's razor is the principle that we should try to keep our theories as simple as possible.
Right, the simplest explanation is usually the best.
Exactly. And so the fictionalist would say that Platonism is just too complicated because it postulates all these extra entities, these abstract objects.
Okay.
And fictionalism can explain everything we need to explain about math without those extra entities.
But do all fictionalists agree with that?
Well, no, actually, some fictionalists think that Occam's razor isn't a very good principle to use in this case.
Oh, okay.
So even that argument is not totally straightforward.
So it seems like fictionalism raises a lot of interesting challenges for Platonism,
It does.
but it also faces its own set of challenges.
Oh, absolutely.
Right, there are objections to fictionalism itself.
Right. So one of the most famous objections is the indispensability argument,
Okay.
which says that math is just too useful in science to be false.
Right, because we use math to describe and explain all sorts of things in the world.
Exactly. So if our scientific theories are true and they rely on math, then math must be true too.
And how do fictionalists respond to that?
Well, there are a couple of main responses.
Okay.
One is to say that math isn't actually indispensable to science.
Okay, so we could do science without math.
Well, not exactly.
Okay.
It's more like saying that we could, in principle, rewrite our scientific theories in a way that doesn't use math.
Okay, so like translate everything into non-mathematical language.
Exactly. But that's a really hard thing to do.
Yeah, it sounds pretty difficult.
It is. It's a very ambitious project, and some people doubt that it's even possible.
Okay, what's the other response?
So the other response is to say that even if math is indispensable to science, that doesn't mean it has to be true.
Okay, how does that work?
Well, it's kind of like saying that math is just a useful tool.
Okay.
It's a way of representing the world that helps us make predictions and do calculations, but it doesn't necessarily reflect the way the world really is.
So it's like a map.
Exactly. A map is useful for navigating, but it's not the same thing as the territory.
Right, but haven't people argued that math plays a more fundamental role in science than just being a useful tool?
Yeah, some people say that math is actually explanatory,
Okay.
that it helps us understand why things happen the way they do.
And if that's true, then it seems like it would be hard for fictionalists to say that math is just a convenient fiction.
Right, that's a real challenge for fictionalism.
And another objection is about the objectivity of math.
Right.
Like, we all agree that 2 plus 2 equals 4,
Yeah,
and that 2 plus 2 equals 5 is just wrong.
yeah, it seems like there's a right answer there.
Right. So if the fictionalist is saying that all mathematical statements are false, how do they explain that?
So there are different versions of fictionalism that address this in different ways.
Okay.
Some fictionalists say that math is objective
Hmm.
because it's based on rules and axioms that we all agree on.
Okay, so it's like a game that we're all playing.
Exactly. And the rules of the game determine what's true and what's false within the game.
Okay. But what about mathematical statements that are undecidable?
Right. So that's a problem for this view.
Hmm.
Because if a statement is undecidable, that means we can't prove or disprove it using our current rules.
Okay.
So does that mean there's no right answer?
Right.
Some fictionalists say yes, but others say no. They think there's still a right answer, even if we can't figure it out.
Okay.
And they have different ways of explaining how that could be.
Okay, so there's a lot of debate, even within fictionalism, about how to handle this question of objectivity.
Yeah, it's a tough one.
Okay, so we've talked about the indispensability argument and the objectivity argument.
Uh.
What are some other objections?
So another objection is that math and fiction aren't really that similar.
Okay.
Like in a fictional story, we know that the author made it up.
Right.
But with math, it seems like we're discovering something real.
Okay, so how do fictionalists respond to that?
They say that the analogy with fiction is just a way of understanding their view.
Okay.
It's not meant to be a perfect analogy.
Okay.
The main point is that mathematical statements aren't literally true.
Because there are no mathematical objects.
Exactly.
Okay, and then there are these more philosophical objections about whether fictionalists can really accept mathematical statements without believing them.
Right, and whether fictionalism can really avoid being committed to abstract objects in some way.
Okay, so those are some pretty heavy-duty philosophical issues.
They are.
Okay, so to sum up, it seems like fictionalism is a really interesting and challenging view in the philosophy of math.
It is.
It raises a lot of important questions about the nature of math, the nature of truth, and even the nature of reality itself.
Right, it really makes you think about what we know and how we know it.
And even though it might seem counterintuitive at first, it's definitely a view that deserves to be taken seriously.
I agree.
So for all you listeners out there, if you're interested in exploring the foundations of mathematics and you're not afraid of a little bit of mind-bending philosophy, I highly recommend checking out some of the work by fictionalists like Field or Balaguer and Lang and all the others that we've talked about today.
Yeah, it's a fascinating area of philosophy.
All right, well, thanks for joining us on this deep dive into mathematical fictionalism,
It's been a pleasure.
and we'll see you next time.
See you then.